Hi, Professor 42 here again with your next C++ debugging lecture. Remember, this is continuing our double linked list debugging with pointers. To remind you, we have a head pointer that points to the first node in the list. Its forward pointer points forward to the next node in the list. And eventually its forward pointer will contain null or zero, saying this is the last one in the list. There'll be a tail pointer pointing back to the last node in the list here at 200. Its back pointer, that node will point back to the previous one at 100, and its back pointer will contain null or zero, saying there aren't any further ones at the front of the list. That's what we're looking at. Then today we'll look at the next problem in our linked list class. We'll presume it works and simply start without debugging and let it run. See what happens. Oops. We had an access violation. We're trying to access memory that doesn't exist in our program. And where are we at in the testing process? Well, we've gone so far all the way down the line till we are at the spot where we're trying to copy the list. We've tested the assignment operator. We have here is the list that we're going to copy. Head pointer points to dog88. At dog88 it points forward to dog Charlie 0. Dog Charlie 0 points forward to Able Charlie 0. Its forward pointer is 0, saying this is the end of the list. It points back to dog Charlie 0. Dog Charlie 0 points back to dog 88, and dog 88's back pointer contains 0, saying we're at the front of the list. That's what we're trying to copy and duplicate. Here's what we've got so far, where our bug is at. We've got a head pointer pointing to Able Fox 8. At Able Fox 8 here, we have a forward pointer pointing forward to Baker 30. Baker 30 points forward to Baker 68. But look at the back pointers. Here's our head, our first node in the list, the front one. Its back pointer should be 0. Up here it's 0. Here it's core garbage. CD, 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 core garbage. So we've got the very first one in the list's back pointer is trashed. However, the one in the middle is working fine. It points forward to Baker 68. It points back to Able Fox 8. So forward and back are fine for the ones in the middle. But notice where we're dying. We're dying trying to output the very last one. Remember the third one in the tail in the list. So it points, here's the node that Baker 68, which was forward pointer was pointing to. However, its forward pointer should be 0. But it's core garbage. Since it's core garbage and it's not 0, our debug display is attempting to display over here a fourth node that doesn't exist. And you can always display core garbage as a pointer. So yes, there comes Charlie dog, Charlie dog, Charlie dog. But when we get down to this point, we're trying to display the forward pointer, which is obviously trash, garbage, and should have been 0. But we're now trying to display the forward pointer for the node that's at core garbage. And at that point, we're getting our access violation, and we're hosed. So let's see what we've got. Where are we at? Well, we are at this spot. This is where we're dying. We're trying to output the forward pointer, but pointer 2 is core garbage. Charlie dog, Charlie dog, Charlie dog. And notice we're in the debug display where we're trying to display either 1-up node or 2-up nodes. And since pointer 2 isn't 0, it's core garbage. Therefore, it's trying to display garbage. And notice when we come down here and look at what he thinks is the link node, he's coming up saying, hey, all 3 pointers in here are trash. So we've got problems with we've got 2 problems. The forward pointer is supposed to be 0 for the last node in the list. The back pointer is supposed to be 0 or null for the first one in the list. Those are the 2 things that are in error, and it's this we're crashing because forward pointer is 0 here, and we're trying to display the forward pointer for core garbage at this spot. So we know the problem does not lie in debug display. It's merely displaying pointers. we got there if we looked at our callback trace. We got there trying to display the output having copied our list. So let's look at copy list a bit. We're trying to copy the double linked list R, and here is our first check. If the head pointer doesn't exist, then there isn't any list to copy. Set everything to 0 or null and get out. Otherwise, we've got to copy everything, and so we duplicate how many items are in the list, in this case 3, and we'll then proceed to set up the process to do the copy. And in this case, our pointer to the current one, as long as it exists, we've got a new node to copy. And what we basically do is allocate a new link node, and then as long as we've got one to copy, we'll go ahead and proceed to store pointer R current's data pointer into the new copied item. And then if the previous pointer exists, set the forward and back pointers appropriately, and then set the previous pointer to the current pointer and allocate a new link node for the next item, and move on down in the list we're trying to copy to the next node. And as long as we've got another node, since we've allocated a new one, we can store the data pointer in it, and if the previous pointer exists, set the forward and back pointers appropriately, set the previous to the current, and go allocate a new one, and move on down to the next one in the list we're trying to copy, until eventually there are no more in the list we're trying to copy, at which point the loop will end, and we can then go ahead and delete the extra new link node that we've pre-allocated. But where in here are we setting our back pointer? Let's look at it from the very beginning, and I will set a breakpoint right there. Now let's run it. We'll do start debugging till we get to this spot. Now let's look at what we've got thus far. Here's the list we're copying. We've allocated a new first node to store this data here, the 18 Fox Baker, Fox Charlie. We want to save that client data in our new duplicated first node. So we need to set a forward pointer and a back pointer, but we can't set the forward pointer yet because we haven't allocated the second node. Let's see what we've got back here. So we've stored the new data pointer. So there's our 1-8 Fox Baker, Fox Charlie being stored. So we're copying the client's data. Previous pointer is 0. But now wait a minute. If previous pointer is 0, we're going to come right down and set the previous pointer to the current pointer and go allocate another link node. But our problem was the back pointer wasn't set to 0. Aha! Here is where our glitch is at. Somewhere in here we need to set the back pointer to 0 for the very first node in the list, and we need to set the forward pointer to 0 for the very last one in the list. There are several ways you can handle it. One could put in special case checking for the very first one in R's list and for the very last one in R's list, but there's an easier way to do it. Here's the lines that I took out of the working program. After we've got our new node allocated, we've stored the client's data pointer in our new node, the one we're trying to copy from the R nodes. Simply set both forward and back pointer to null or 0. And then if we have a previous pointer, we can also adjust the back pointer and forward pointers as necessary. But this will guarantee that our forward and back pointers are always going to be something other than core garbage. Now let's assume that it's working, and we'll see what happens. And Viola, no memory leaks, and our copied list is now working perfectly. And we've again solved another debugging problem. Good luck.